Today's program is saddle point. We have to find a number which is maximum in its column and minimum in the row. This is the program. It is a little bit complex, but let's break it down. I'm CJ and welcome to Education Value. Today we have another amazing video on the Java program, so let's do it. So we will go row by row and find the smallest number in the row. After when we have found the smallest number row, we will try to traverse that column and find the biggest number in that column. If both the row r min and the c max are the same, it is a saddle point, otherwise it is not. So this is the code. So we just normally take the size of the matrix, we reverse check if the size is in the range or not, which is if the size is a reasonable number or not. Sim.out.println, enter the numbers on the array. When they take input in the array that we have asked the size for, then we print the array for the user to see what the array inputted was, because when we are inputting numbers, it is in a linear form and not displayed properly in a matrix format. After that, we find the saddle point. This is the simple, a little bit complex, but line for saddle point. So first we take our minimum at the I0 position. I0 position means we take it at the first position, the 4 and the 7, which is the when I is equals to 0, j is always 0. When I is equals to 1, j is also 0. When I is equals to 2. So we take the first column of every row to first assume it if it is the smallest number in the row. After that, we will check if it is actually the smallest number or not. If it is not, then we move to the one which is actually the smallest number. And we also take, for example, let's say this was the smallest number, we will also take the column value of that number, and for let's say, for example, in the first row, third number was the smallest number, so we also take the column value of that number and we check in that column which number is the highest. So for example, then we found this number to be highest. Then after that, we directly check if this number and this number are the same. If both of those are same, then it is a saddle point, otherwise it is not. That's how we go about the program. And for declaring every time, like for initializing the c max, which is column max, we use 0. Like column row will always be 0, and we will take whichever column it will be the row has found this minimum number in, which is x here. Okay, so that was the program. So for row we will run a separate loop, and for column we will run a separate loop, and we will do swapping if we found a smaller number, we will do swapping if we found a bigger number. That's pretty simple. After that, we directly check if it is a saddle point or not. If it is a saddle point, we make a variable ++ to find its frequency, and if f is equals to 0, no saddle point, else number of saddle points is +f, because a loop can have more than one saddle point. Also, whenever the c max is equals to r minimum, like the maximum in column is equals to minimum in row, we directly display that saddle point as well. So let's do this example, go through this example to find the saddle point of this matrix. Okay, so find the saddle point. R minimum is equals to I0, column value, like row column. This is so row will be 0 and column will also be 0. After that, we declare this loop. In the loop, we will go through, like j will keep increasing, and I will of course remain the same because we are traversing one row. So j will keep increasing, and we will uh, check if the number we find a smaller number or not. We will check with 2, we will compare 1. The r minimum has right now 0 0 position, so 1 it has, and we will then j will go to 2, then j will go to 3, and check if it is a smaller number or not. If in case we find a smaller number, the column value will change to whichever the smaller number is, and r minimum will have that number as well. Okay, so we have found 1 to be the smallest one, which was already assigned before. Now the loop will not do anything in this case. The cmax will also be declared. The call row value is always 0, it starts with 0. So all the r minimum, like row minimum values, are starting with the first column position. All the column max values are starting with 0th row position. That's what we are assigning, and then changing if it is necessary. Okay, it is starting with 0th row position, and whichever is the minimum one found. Okay, then we have still we have 0 0 at in here too. So we will the k loop will go through the whole 0 1 2 and compare if it is small, if it finds a bigger number or not. If it finds a bigger number, cmax changes to that number, so it will change to 4, then it will change to 7 here. If cmax is equals to rmin, if cmax is which is 7, rmin was 1, equal, no it is not equal, so this part will not be executed, and the loop will move to the next value of I. Next value of I is 4 in this case, 4 0, like 1 and 0. The same thing will happen, it will be declared, and then it will check with 5, it will check with 6, it is whether it finds a smaller number or not. In this case it will not find, so it will remain at the 1 0 position, and the x will remain 0 because that's the smallest one. So since x is 0, so the largest number check will be done in this column only. So cmax will be 0, like this. Cmax will be 0 and x is also 0, so it will compare 1 with 4, it will go down to 4. At this point in time, it will assume that we have found the cmax is equals to rmin, but one more iteration of the column is left. So one more iteration of the column, it goes to the next number to check if it finds a bigger number or not. Yes, it found a bigger number, so cmax and rmin become different. C minimum, like the minimum in the row is 4 and the maximum in the row is in that column is 7, so again it is not a saddle point. So the loop moves to the next I position, which is 2. Now it declares 7 as, like, r minimum is equals to I and column is 0, I 0, I is 2 and 0 is 0, column is 0, so it declares 7 as the r minimum. Then it compares with all the others, it compares with 8, it compares with 9 if it finds a smaller one or not. Apparently it did not find any smaller one, so r minimum remained at 7, x value remained at 0. Okay, so x value remained at 0, then we declare cmax 0x. X value was 0, cmax is 0, so it remains at 0th position, 0 0. So then it will check if it finds a smaller number or not. So it did check with 4, yes it is smaller, cmax becomes 4. Then it checks with 7, Cmax becomes 7. After that it performs the check, Cmax is equals to armin or not. Yes, Cmax is armin, so the saddle point is 7 of this matrix. After that there is no iteration left. N becomes I becomes N and the loop terminates. Loop terminates if f is equals to 0, no saddle point. This is not true, so else will be executed. Number of saddle points is 1. So this was the program. You just declare or just assume one place in that row it at the 0th position and check if it finds a smaller number or not. If it finds a smaller number, update the column value to which is in X. Okay, once you updated the column value, you assign that column value in Cmax because you have to check in that column only. Saddle point is it should be smallest in its row and be highest in the column, so you assign that column to the Cmax. You assign that column, you use the 0th position of the row to start the job. 0th position of every time you start with 0th position, 0th position, 0th position. In rows you start with 0th position of column. In column you start with 0th position of the row, and in column as well we use the whichever the smallest number was found at that column, but it should be in the 0th position of the row. Once we have find that, we again compare if it is the biggest number or not. We find the biggest number and assign Cmax to it. After that we just run a check and find the saddle point or not. So that was the program. Let me run it once. I have the matrix 3, 1, 2, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Saddle point is 7. Number of saddle points 1. So that was the program for saddle point. Thank you.